All right, so today I want to talk a little bit about architecture of Vendasta and how we kind of got to where we are today. I really hope no one here came for front-end talks because this is, again, fully back-end, but that's all right. But first, let me introduce myself. My name is Jonathan Baxter. I've been at Vendasta for around 5 years now. I've been on multiple teams, lots of different roles in engineering. Currently, I'm on our site reliability engineering team. That's probably a topic for another talk, because today I really want to focus on our architecture and kind of how we've built our software over the years. So I'm sure lots of you in the audience are familiar with what Vendasta does. I'll give a quick plug. I'm sure some of you here were around when some of these architecture decisions were made. Probably can correct me where I'm wrong. Anyways, Vendasta, what we do at Vendasta is we build small to medium business software for these businesses to be able to keep up in the modern age of the internet. We build e-commerce products, we build marketing products, and we sell these products to trusted local experts. And basically, I don't really want to pitch Vendasta, but basically this all ties in. What we do is we build a white labeled platform for these partners to resell marketing and e-commerce solutions. So where did it all start? So Vendasta did a few things before we moved into this building, and this is before I was there. A few of you in the audience, I think, were at this building. This is on 33rd Street. But by the time we moved into this building, we've kind of figured out what we were going to do. We wanted to build a reputation management and presence software. This was called reputation management. Well, it is now. It had a different name then, but that's not important. And that's kind of where our story starts. But before we get into that story of how that was built and how that was architected, I want to talk about one thing first, and that's Conway's Law. I don't know how many of you have heard of Conway's Law, but what it states is any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. So what this means is the communication structure within your company is going to be reflected in your software. And it's kind of interesting to look back at Vendasta's past and how this has evolved over time and how it's actually kind of followed this. So where we started. I Googled monolith and clicked the images tab, which weirdly on Google is now way further down than I remember. And this is the first picture that showed up, so I decided to use it. So where we basically started out with a single product called reputation management, as I mentioned, and we started out with a monolith. For those of you who work at Vendasta or have worked at Vendasta, you might recognize the little guy on the left. But yes, I heard someone say that. So ever since the beginning, Vendasta has built our products on top of Google Cloud. I think at that time when we started, it wasn't called Google Cloud. I think it was just Google App Engine. So that was the tool that we used. We built it using Python 2.7 and a Google database offering called Data Store. Now, we still use these technologies today, but we definitely had a lot of limitations when we started, both from a tech space and just from what was available at the time. For example, Data Store is a non-SQL database, which was relatively new, I think, at the time. And it really allowed us to move fast. Document Store, really easy to use. Definitely had a lot of limitations around transactions and how different entity groups worked, but we worked around those. One of the big pluses that we had about using Google App Engine and using Python 2.7 specifically was, I think at the time, the development culture in Saskatoon was not as large. So it was easy for us to onboard new devs because Python's a relatively easy language to learn. If you have some development experience, it's not that hard to use. Cool. So a little throwback here. Cody, I think you'll appreciate this one. So with this original monolith, we built this reputation software. We started to add new features. We added social marketing. We added more listings. So what a listing is like on Yelp, you go to yelp.com, you type in, I don't know, Amigos Cantina, and that shows up, that's a listing. So we built listings, we built all these different pieces. And as the business requirements changed, we realized some of our customers didn't want to sell a single solution, they wanted to sell multiple solutions. So we started to break these apart, and that original monolith that was RM became reputation management, or RM for short, I should say, split up and became these different products. So we had a social marketing product, we had a listing product, and that worked out well. But one of the downsides we really realized is as we started to break apart these products, they ended up sharing a lot of code paths. So for example, you may want your reputation management product to show your Facebook reviews. And to be able to do that, you need to have authentication with Facebook to grab that data. Now, you might want your social marketing to be able to post marketing material to Facebook, sponsored ads, that sort of thing. And the real problem there becomes is you end up building Facebook authentication twice. So what we ended up doing is we took these multiple monoliths, extracted all the shared code, built one very large monolith called core services. And basically these other services such as listing builders, what one of them's called, social marketing, reputation, was more of a veneer over top with a lot less of that heavy lifting being done by that underlying monolith. So this was really the start of us moving towards a service-oriented architecture. Now, App Engine definitely had some pros and some cons. At the time, I don't really think there was much that could scale in the same way App Engine was. It was really easy to deliver it. It was really easy for it to scale up and down. You didn't have to worry about adding more servers. All that was done for you. But it did have some limitations. So the way App Engine works is it was inside of a sandbox. So basically, Google installed all your requirements for you, and that's pretty much all you could use. And this really led to some downsides. One of the biggest drawbacks with App Engine, and we built a very complex system to get around it, is it has a 60-second timeout on HTTP requests. So basically, you can do work for 60 seconds, and then you need some way of continuing that work. So I ended up building a finite state machine framework, basically, that allowed us to get around this. Some of the other limitations, and this is, I think, one of the big ones that really made us shift to a different architecture and a different technology stack, was the serialization. Within App Engine, all the serialization is done by Python 2.7, versus when you're outside of an App Engine environment, your serialization for JSON serialization can be done by a C library. So basically what we ended up having is we had a lot of overhead on all of our requests just due to serialization and deserialization. So really there's no way you can optimize it. So if an API was slow, it was even slower. Or if an API had a really large request, you're gonna have a really, really slow time serializing and deserializing. So we had all these monoliths, they work great, right? Nah, not so much. Another thing that really came up was with having this single large core monolith, our build times really started to increase. Python 2.7 projects are really hard to refactor. I don't know if any of you have ever used an untyped language, but it's not fun, especially when things are named the same. Back on build times, core services, like that was starting to take 30, 40 minutes to build, maybe even longer. And that was really slowing down. And the other thing was, especially when something broke, you had a bad build, you're looking at 80, 90 minutes just to roll back and get a new change up. So that was starting to hurt us. Another thing we realized is as our business requirements changed to Vendasta, we need to be able to introduce new technology. So for example, the big one, I think that really sticks out and really started moving us forward was Elasticsearch. This is a technology we still lean on today. At Vendasta, we recently did a migration from Elastic 2.4 to Elastic 7, which is kind of crazy. It took us that big of a jump. But basically with this Elasticsearch, we ended up spinning it up on Kubernetes. And that was kind of the first thing where we're like, hey, if we're gonna break one thing out of the sandbox, why not break out more? So as the company started to grow, and we moved offices at some point in there, another big, one second here, so. As Vendasta continued to grow and our organization became more structured, this is kind of where Conway's Law comes in again. We had all these products, we had multiple products, multiple different teams, and we really started diversifying. And it kind of looks, it's kind of interesting because you look at this as we started to split up, we started to get more teams, and those teams started to take more responsibility of that shared core service. And really it's following Conway's Law because now what you're having is multiple teams communicating within each other and a shared ownership. So around 2014, Python announced that they'd be sunsetting Python 2 in 2020, which they did. I think even before that, they had an earlier sunset date, but I don't remember for sure. And since our entire platform was built on top of Python 2, we started to look to what were we going to switch to. Python 3 was definitely an option, but for reasons that I'm not 100% sure, we decided on Golang. And there's definitely some pluses to Golang, but maybe someone here knows why we chose Golang for sure. But we took that plunge into Golang and started to build more of a service-oriented architecture. Some of the real pluses with Golang, and it does have some negatives like anything, but number one, that faster serialization, deserialization, that made like Golang is crazy, crazy fast for web servers. It's really, really performant. Strongly typed language, this was a big change for us, moving from Python, which is interpreted, to something that's actually compiled. I think that was a really good change for us, made us easier to refactor, and made it a lot easier for us to write safer code. I don't know if again, with an untyped language, you could ship something, not realizing that you had this type versus this type, and it just breaks. And yeah, another big plus for us with Golang was it's just fast. Like tests are really fast to run on your local machine. They're easy to set up. Dependencies are easy to manage now that Go mod's a thing and not Yarn. No, what was it? I can't remember. There's a bad one. And then the other thing as well is builds. We're able to build very, very small containers that are very easy to ship. They're easy to move those images around. So that's really awesome. Around the same time, we started to make the switch as well to gRPC as our transport protocol. The really nice thing with gRPC for us as we move towards a service-oriented architecture was the ability for us to define that strong interface. If you're not familiar with gRPC, basically what you do is you end up writing an interface, a contract, if you want to say, between exactly what the APIs are going to look like. And this is really nice, especially with a language like Go, which doesn't have any inheritance, because that means it makes it easy to generate SDKs. It makes it easy to build documentation around those APIs. So that was another big win we got there with moving towards Go. As I previously said, we had a little bit of a Kubernetes experience with Elasticsearch. And as we started more down this service-oriented architecture, we started to spin up these services in Kubernetes. It seemed like a good fit. We've always used the Kubernetes offering from Google, GKE. And really some of the big wins we got here is App Engine's a bit of a hammer. And I think GKE or Kubernetes is a bunch of smaller hammers. So you're able to tweak things, not as much as maybe you'd want to, but you're definitely able to tweak a lot more things and control your scaling. And yeah, there's definitely been some ups and downs for Kubernetes with us. I know over the years we've had a lot of issues with load balancing. Probably a year ago-ish now, we rolled to using Istio Service Mesh, and we've seen a lot of success there. And that's given us a lot of power and a lot of safety for our developers on rolling out new builds and that sort of thing. We have a lot more coming that way at Vendasta. So as Vendasta grew from a few devs to, I don't know, we're probably about 120 now. R&D's maybe 150, 160. We had a lot more independent teams, and we wanted to make sure these teams could manage, spin up, do whatever they needed to with these services. Right now, I'd say we're 100 plus microservices. Most teams have a few, and we've got about 20 teams. And we really want to focus on making that an easy process. Now, definitely want to be careful with when you're spinning up services. You don't want to end up like Netflix. I think it's like 2,000 microservices. But yeah, I kind of want to touch on that a bit as well. Throughout this presentation, I've kind of talked about service-oriented architecture and not microservices. I do think where we started was with going down the microservice path, but I really think we more ended up at a service focus. So like the definition of a service-oriented architecture is basically like it's built in response to a traditional monolith. The SOA breaks up components required for applications into separate service modules that can communicate with one another. So really the difference is service-oriented architecture is more focused around business requirements and business objectives, whereas I think a microservice architecture is more focused about individual technology. So say, for example, in a service-oriented architecture, you maybe have a large billing service, and that does all your billing. It produces your billing reports. And maybe it's not what sends them, but it produces those for you. Whereas in a microservice, you might have one microservice that only does credit card transactions. You might have one microservice that does checks or something, right? So that's kind of the main difference there. And I really think we focused on services. I think one of the big takeaways that we've had around service-oriented architecture is when to split out another service. We've definitely made mistakes. Off the top of my head, I can think of a couple services that maybe should have been stuck together. But we've definitely learned that when we want to split out is really when we need different scaling characteristics. So say, for example, you have a very compute-heavy piece inside of your service. If you can extract that out, it's going to make it a lot easier for you to manage that service and scale it however you want. So, for example, I'm trying to think of one of our good examples. Whatever. Now I can't remember it. I had one. Anywho. The other thing I want to talk about, and Richard, you'll like this, is API first and our focus on APIs. When we first started out, and around the same time as we started to make this more of a switch towards Golang and Kubernetes, we would build we'd build our product. We rendered everything server-side using Knockout. And then our customers would come and say, hey, I love your software, but I want to plug it into my stuff. Do you have an API for that? And we say, okay, cool, like we'll build you an API. And they never stayed in sync. We'd build some feature for the front end and for our rendered view of it, and we forget about the API would break, we weren't using it, yada, yada, yada. So as we move towards this more service-oriented architecture, we took that API first approach to make sure that we were building those APIs and had those available to our customers if they wanted them. It also allowed us to move from that server-side rendering to our front ends are now all in Angular. I want to talk a little bit about some of the different technologies that we have built over the years internally, and then I want to talk about some third-party ones that we're using to make it easier to spin up these microservices. So one of the downsides of having a service-oriented architecture is that you have 100 services. That means you have 100 databases that you have to manage. You have hundreds of load balancers. You have hundreds of different pieces you need to take care of. So some of the decisions we made that have worked out well for us, and I think a lot of this is because we've leveraged Google Cloud Platform, is building centralized tools for this. So one of the best examples would be vStore. This is one of our centralized databases. So it's just another service, and this is what we use for all of our data storage needs. This is built on top of Google Cloud Spanner, which is a distributed Postgres. I don't know if it's actually Postgres, SQL instance. And it has been really good for us. So basically with vStore, what we have is we have more or less a key storage with a little bit of querying ability. But the real genius or the real plus of vStore is its guaranteed secondary indexing. So say, for example, you have a model for an account, and you want to add search to that. Searching in SQL, not always, full text searching in SQL, not always the best thing, not the most performant. Elasticsearch is great for that. What vStore lets you do is it lets you define a secondary index, say Elasticsearch, and then it guarantees that that data will get there, so you have eventual consistency, and it's pretty performant. I would say sub a few seconds for sure. On a bad day, maybe sub a few seconds. And this guaranteed replication has made it really easy for teams to add those new search stacks, to add new databases. If you want to do aggregations, you add MySQL. If you want to add something crazy like, I don't know, Solar, we also have that built in, so you can just secondary index via a PubSub, Google PubSub, which is more or less a messaging queue, and then that will index for you. So this has really helped our teams. So it's reduced the overhead we need for running a database for every service. It's helped teams not have to worry about the database as much. There's definitely some downsides to this. One I would say is just that noisy neighbor problem. If you have one really bad neighbor, you're going to take out the whole thing. But luckily, we've had pretty good luck so far, and the backing technologies we've built this on top of are really scalable and really well distributed. The other one I want to talk about is a tool called Mscli, and that's why I touched on microservices. So this stands for Microservice Command Line Interface. Now, we built this tool basically, so one of the big downsides of Go, as I said, is generics and inheritance isn't really a thing. So that means you have a lot of boilerplate. The plus side, that makes things really fast. For example, error handling in Go, every time you call a function, it'll return you an error and you check if that error is nil. Annoying, but really fast. Much, much faster than wrapping and catching errors. So we built this tool called Mscli, and this basically makes it so that a team can easily spin up a new microservice if they need to, and it helps manage their microservices. So Mscli will bootstrap your microservice, it'll set up the code for you, it will provision all of your IAM, all your necessities, can help you generating some of your database. If you provide a schema, it'll generate your database models for you. And basically the big thing here that Mscli has given us is when you have that many services and you have DevOps or SRE, you need to make it so that those SREs are able to jump into a service, understand what's going on and fix it, or be able to help you with it, or just in general have that consistency across. And this has really lent us towards having that consistency. This way we're able to know that, like, hey, when I jump into my service, there's going to be a model, there's going to be a repository, there's going to be a service layer. Those are going to be there, I'm going to know where they are. And basically it means our services more or less act in the same way. Now, downside of this is when we make a mistake in the way we've generated that, it's a real pain in the butt to fix. But I think overall it's worked out quite well for us, and it's made things pretty easy on our developers, especially for onboarding. It does hide a little bit of the complexities, especially around setting up Kubernetes and provisioning pods and deployments and all that. But I think it does help developers be able to jump in and get working right away. So I want to touch on a little bit what's the future of Vendasta's architecture. I want to talk a little bit about two technologies that I think one's pretty ingrained at Vendasta now. I think one's coming pretty soon. But yeah. So the first one I want to talk about is Uber Cadence. Has anyone here heard of Uber Cadence who doesn't work at Vendasta? Perfect. So Uber Cadence, or Temporal, which is another offering of a forked version of Cadence, is kind of is really a key piece to a distributed system. What Cadence does is it lets you define workflows that can cross multiple different microservices and are fault tolerant. So really the big plus there, oh, I forgot to change my wording on my slide. Ignore my slide. The big plus of Cadence is it lets us make sure that, hey, if one of our microservices goes down with a workflow, maybe you have a workflow that crosses 4 or 5 microservices. So say, for example, in Raul's case, when he's talking about, hey, billing someone canceled, we have to let scheduling and we have to let reporting know. What we would do then is we would have whoever's in charge of that kick off a workflow, and it would orchestrate those calls across those different services. I think it's a really cool concept, and with that distributed system, I think it's becoming more and more central to how you work in that environment. But yeah, if you haven't checked it out, it's definitely worth taking a look at. It's pretty cool. The other one I want to talk about, which I'm pretty excited about because I've been more involved with the rollout of Vendasta this, is Argo CD and Argo rollouts. So CI is always kind of a tricky thing. Building containers, shipping containers, deploying containers. It's always, I don't know, I feel like it's always a little fussy. So, and we've gone through different iterations of this. We had Team City, we had Jenkins for a while, and then we moved to our own in-house built version called Mission Control, and now this seems like maybe part of this will be the next iteration of that. So what Argo CD is it's specifically built for Kubernetes, and it's basically just a build for running your kubectl apply, your kubectl deletes, all that for you. And it gives you a really, really nice graphical interface, and I think that's the biggest win here, as you can see kind of in this GIF, is when your service spins up, spins down, when your load balancers come up and down. Heck, even if you want to define your secrets inside of your GitHub repositories, same thing. You can see it all there. You can see it's all running, and you can click into it, and it makes it a really good explanation of what's going on, so that you're not hiding a lot of those complexities that some other tools do. And this is working on top of GitOps, which I think is another really interesting way of delivering software, and using that versioning to be able to tell, hey, who made what change is really, really, really nice. Yeah, so at the end, I just want to leave some time for questions and just a couple quick final thoughts. It's really interesting, like as we move forward in Conway's Law, as we've grown as a company and split, I think we're over 600 people now, and the engineering division has grown as well. It's really interesting to see how our architecture has started to split up, become more independent, so one team isn't stepping on another team, and allowed multiple teams to deliver all the time. I think per day, we're probably shipping to production 200-300 times. So it's really allowed us to move quickly and iterate for our customers. I want to give a quick plug. Vendasta is hiring. If what you've seen here interests you, feel free to talk to any of us who are wearing Vendasta shirts, and maybe just a couple of us. We're always looking for people who are interested in this kind of stuff. And yeah, if you have any questions, come find me, or you can ask them now if you want. That's it.